So if you filled out this logic table correctly, this is what you end up with. I'm going to spend the rest of the video explaining how I got this answer. But if you got this answer, you're doing it correctly. Well done. And I'll say, the question is, was this statement up here a tautology? Meaning, is it always true no matter what? And we can see that this is not a tautology. Sometimes it's false. So I'm going to go ahead and pause this and delete all my stuff and explain how I got this answer. But if you're cool with this, you can just hop on over to the next video, and it should be all hunky-dory. Let me pause. So if you're sticking around, here's what I want to say. We got the truth table in front of us. The whole goal is to find the ultimate value, all possible values for this statement, and to determine if it's a tautology or not. We set the table up so that we only had to look at one, maybe two columns at a time. And some advice I'm going to give you guys who are maybe having a hard time with this is, throughout the class, I've talked about things like, this kind of statement's only true when this happens, or it's only false when this happens. So for each type of thing, there's some kind of thing where I tend to hone in on it. And I'm going to use that here. Rather than like go through every single like row, I'm going to be on the lookout for when is this guy true or when is this guy false. And depending on if it's an and or an or a conditional statement, I have different rules that I apply, and you're going to hear me verbalize them right now. But the goal is to just think about one thing at a time. So given everything else, this is all for us for free. I want to first find the values of not m. I'm simply going to look at the column labeled m and put all the opposite values. So any place m is true, this column is false. Any place this is false, this column is true. So it becomes f, f, t, t. And then I'm going to put that out of my mind. I'm not going to worry about it right now at all. I'm going to go on to not n column, meaning I'll look in this column over here. In any place this is true, this will be false. If n is false, not n is going to be true. I'll be going false, true, false, true. Now, here's what I'm talking about for the next part. Here's a situation where you'll hear me say, as weird as this may seem, this is going to only be false when this is true and this is false. Right? It's something I've got to memorize or know at least that there's a thing to look at there. The conditional statement is true when the beginning is true and it leads to a false conclusion. So now what I'm going to do, instead of going through each row and trying to figure that out, I'm going to look right now specifically for where not m is true and where not n is false. So I'll be using these two columns, and I'm not even looking at these first two rows because it's not even a thing. I'm just looking for this is false right now. This is false when not n is true and not n is false, so it's false here. That's the only place I saw that happening, so I'm not even going to look at the other rows. I'm just going to say they're all true. I'm not going to worry about it. So that's what I mean. I've got this exception that I look for. Conditional statements are pretty much always true. They're only false when the beginning is true and the ending is false. Let me look for that exception. And statement next. This and statement involves not m and n. So for first things first, I'll be looking at the not m column and the n column. And I know the exception here is it's hard for these to be true. So I'm going to use a slightly different rule, but what I'm going to say is only true if both are true. So I'm going to look in these two columns for a place where they're both true. So if I see any f's at all, it's not even in, I'm not registering it. I'm looking at these two columns. So no, okay, here's a place where it'd be true. I'll mark that. I don't see any other place where it's going to be true. So I'm going to mark everything else with false without even really giving it too much thought. Now, for the coup de grace, the grand finale, we'll be able to answer the question if this is a tautology or not. Is it always true or no? I don't know. Let's find out. But again, I'm going to work with that exception. I'm seeing here a conditional statement. This is supposed to imply this. So this is going to only be, well, what's the exception? It's hard for these to be false. These are only false when this part is false and this part is true. So I'm going to look in this column, and I'm going to look in this column. And if this is marked as true, I'm going to give it a special attention and see when this is true, is this false? When this is true, is this false? So, oh, I see lots of places where that happens. That happens here. True implies false, that would be false. True implies false, that would be false. True implies false, that would be false. So by keeping my mind on that thought, I'm like not having to switch gears constantly. I'm just looking for where am I going to mark this thing as false. And mark all those as false. And then anything that's left is true. So that's my final value. And what that tells me is this statement is not a tautology, which means the next one probably is. But let's see how that plays out. But definitely, like, no matter what, like this gives me all possible combinations of values for m and n, and this is what happens at the end. So I know for sure it's not always true. That's how that worked. I hope that's helpful. Let's try the next one together as well and see how it goes.